Hello, this is AQA Pure Core 1, January 2011, question 4, and it says that the curve sketched below passes through the point A, which is minus 2, 0, so it's on the x-axis, and the curve has the equation y equals 14 minus x to the power of 4, and the point P is 1, 12, and that also lies on this curve. So these 2 points lie on this curve. Okay? The question then says, find the gradient of the curve at the point P. Okay, so what we want to do to find the gradient is we want to differentiate this, the equation of the curve. So dy over dx equals, differentiating 14, well, there's no power of x, so timesing it by 0, you just get 0, that just disappears. Minus x, differentiating that, the power of the x is 1, and so we want to times by the power, which will be 1, and then remove 1 value of x, so we get minus 1. And then minus x to the power of 4, so we times by the power, which is 4, minus 4, and then minus 1 away from the power, which will leave us with 3. Okay, so this is this differentiated, and we want to find the gradient at the point P. So we just want to substitute this into this. So the x-coordinate of P is 1, so minus 1 minus 4, 1 cubed equals minus 5. And that's your answer. So the gradient at the point P is minus 5. Okay, so the second part of A, it says hence, which suggests that you use the part before. Hence, find the equation of the tangent to the curve at the point P, giving your answer in the form y equals mx plus c. So our tangent is a straight line, and we know that y equals mx plus c is the general equation of a straight line. So basically, we have, for this point, we have the gradient, which is minus 5, and we have the point, which is p, which is 1, 12, and we know that if we have a gradient and we have a point, then we can use the formula y minus y1 equals m x minus x1 and sub these two into this, okay? So let's go for it. Y minus the y coordinate, which is 12, equals m, which is minus 5 with the gradient, x minus the x coordinate, which is minus 1. And it's asking for it in this form. So this is the equation of the line. Writing it in this form, we just need to multiply out this bracket, which is minus 5x plus 5. And moving the 12 over to the other side, we're going to get minus 5x plus 17. And this is your answer. Okay, so part B. The first part of part B says find, and then it just gives you this. So the integral of 1 with the limits 1 and minus 2, 14 minus x to the power of 4 dx. Okay, so let's integrate this. So 14 integrated, you add 1 to the power, 14x, and divide by the new power, which is just 1, so divide by 1, it's worth writing that, I suppose, minus x squared, because you're adding 1 to the power, divided by the new power, which is 2, minus x to the 5, because you're adding 1 to the power, dividing by the new power, which is 5, and we've got our limits 1 and minus 2. Okay, so we're first going to sub in our higher limit, which will make it 14 times 1 minus 1 squared divided by 2 minus 1 to the power of 5 divided by 5, and then we're going to minus, subbing in our second power. Okay, so 14 times minus 2 minus 2 squared divided by 2 minus 2 to the power of 5 divided by 5. Okay, and this all comes out the wash as 14 minus 1 over 2 minus 1 over 5 minus 28 minus 2 plus 32 over 5. And when you just do all of this adding and subtracting, and be careful of the double negatives here when it comes to this, when it comes to figuring this second part out, we are left with 36.9. Yeah, so it's just worth taking your time, because you don't have a calculator to double check in this exam, just taking your time to properly, you know, manipulate all of that and add it and subtract it all out properly. Okay, so the final part is part 2 of B. It says hence, again, so hence means we're going to use the part before. Find the area of the shaded region bounded by the curve y equals 14 minus x to the power of 4 and the line AP. Okay, so we know that, so if you look at the diagram in the question, we know that okay, so it looks a bit like this. The curve does, and the line AP goes from minus 2, oh that's a really bad line, sorry, and we know the x coordinate is 1, and the y coordinate and the x coordinate here is minus 2, and this is the shaded region. Okay, so we know that the area under the curve, the question asks you, hence find the area of the shaded region. So it wants you to know this, it wants you to find out this area. Okay? So you know that integrating between these two values will find you this whole area under the curve, but you just want this part of the area, so you need to work out what the area of this triangle is here. And so this point is, remember this point is 1, 12, and this point is minus 2, 0. Okay, so to work out this area of this triangle, we just go, and again, this is one of them questions that kind of separates the A's and the A stars. So the triangle is a half times 3 times 12, because that's a half of the base times the height, which is the equation to find out a triangle, which is 18. And we know that this total area under here is the 36.9. So you minus the 18, and we know that the area of the shaded region is therefore 18.9. And that was quite a hard question. But I hope that that was helpful, and thank you for watching.